Hi everyone, welcome to Differential Calculus. Today we explore lesson 4.9 anti-derivatives. Number one, anti-derivatives definition. A function f is called the antiderivative of f on an interval I if f prime x equal fx for all x in I. Let's take a look at an example here. Example, phi fx f of x is x squared plus 1. The antiderivative is going to be a function, so that the derivative of that function is f of x. Well, in order to get x squared, we need x to the power 3. And then when we use the power rule, we have a 3 in front, so we got to divide by 3. And as for 1, the derivative of x is 1, so the antiderivative of 1 is x. That is one of them. Reason why I say this is one of them is because fx can be fx equal to x3 over 3 plus x plus 1, fx equal x3 over 3 plus x minus 1, fx equal x3 over 3 plus x plus 1 over 2. What I have in the box is called a particular solution. And in general, we would have the antiderivative to be x3 over 3 plus x plus some real number. We call it a constant c. C is a constant or a real number to be determined. This form right here with the plus c, let's call it the general solution or antiderivative. Yeah. Let's take a look at a table of a particular antiderivative. General versus particular antiderivative. Definition: if f is the antiderivative of a function f, then the general antiderivative of f is fx plus c. The particular antiderivative of f is fx, and we set c equal to 0. We have a bunch of functions and their particular antiderivative. The antiderivative work for a constant multiplicative of function. The sum or the difference between two functions. For x to the power n is not equal to -1, then the particular antiderivative is x to the n plus 1 over n plus 1. When n equals -1, that is when we have 1 over x. Antiderivative is ln absolute value x. We need the absolute value because ln is undefined for negative number. Antiderivative of e to the x is e to the x. Antiderivative of b to the x is b to the x over ln b. Antiderivative of cosine x is sine x. Antiderivative of sine x is negative cosine x. You got to be careful on this one. This is because the derivative of negative cosine x is negative. Derivative of cosine x negative sine x. So have negative of negative sine, which is sine of x. Yay! Antiderivative of secant square x is tangent x. Antiderivative of secant x tangent x is secant x. And antiderivative of 1 over root of 1 minus x squared is arcsine x. Antiderivative of 1 over 1 plus x squared is arctangent x. Antiderivative of hyperbolic cosine x is hyperbolic sine x. Antiderivative of hyperbolic sine x is hyperbolic cosine x. It's a pretty useful table. Very useful in the next course in calculus, call it integration or integral calculus. Let's do some example. Example. Find the general antiderivative fx equal to x squared minus 2. Well, we cannot do this directly, so we have to FOIL it. First, x squared minus 2 times x squared minus 2, and this gives us x to the 4 minus 2x squared minus 2x squared, so minus 4 x squared plus 4. Now the antiderivative is antiderivative of x to the 4 x to the 5 over 5 of x to the second is x to the 3 over 3 of 4 is 4x, and we plus c because it is the general antiderivative. We can simplify this, make it look nice. 1 over 5 x to the power 5 minus 4 over 3 x to the 3 plus 4x plus c. Wow, that's cool. In b, fx equal e to the x minus 2 over x. E to the x, 2 to the x is 2 times 1 over x. And now we can take the antiderivative. Antiderivative of e to the x is e to the x. Antiderivative of 1 over x is ln absolute value x. So I need 2 times ln absolute value x. Fx equal to 2 sine x minus secant square x. Example C. Well, we can do the antiderivative right away. Antiderivative of sine is negative cosine. 2 times negative cosine x. Antiderivative of secant square is tangent. And then from here, it's negative 2 cosine x minus tangent x. In D, we have a quotient, fx equal to x squared minus 1 divided by or over 2x. Cannot take the antiderivative directly. We have to split the fraction and simplify. It is x squared over 2x minus 1 over 2x. So that is 1 over 2x minus 1 over 2 times 1 over x. And now we can take the antiderivative of each antiderivative of x is x squared over 2. Antiderivative of 1 over x is an absolute value x. Simplify, we have 1/4 x squared minus half an absolute value x. Very nice. One more example. In the last example, by the function fx given the second derivative is 2x plus 3e to the x, and some initial condition on the first derivative and the function itself. F prime 0 equal 1, f of 0 equal to 0. From the definition of antiderivative, if second derivative is 2x plus 3e to the x, then the antiderivative of the second derivative is the first derivative. So f prime x is 2 times x squared over 2 plus 3 times e to the x. That would be plus c, because we always use the general antiderivative. From there, we do the substitution to solve for c. Sub f prime 0 equal 1. So 1 is equal to 2 times 0 plus 3 times e to the power 0 plus c, where we have 1 is equal to 3 plus c. C is -2. From here, we see that f prime x is x squared plus 3 e to the x minus 2. Similarly, we use the idea of antiderivative and figure out the function from the first derivative. The antiderivative of the first derivative is the function fx. Antiderivative of x squared is x to the power 3 over 3. Antiderivative of e to the x is e to the x. Antiderivative of 2 is 2x plus c. To solve for c, we use the initial condition f0 equal to 0. Sub f of 0 equal to 0. And we have 0 equal to 0 plus 3 e to the 0 minus 0 plus c. So 3 plus c equal to 0. C equal to 3. And from there, the function f of x is 1 over 3 x to the 3 plus 3 e to the x minus 2x minus 3. Ta-da! Very cool. Yeah, what we have done right here is a very small process in solving differential equation. Differential equation is an equation that have derivative. So far, we solve for this using the initial condition to get the solution, and the solution is the function fx. Pretty cool, huh? Thank you for watching. I hope you find the content useful. Please like and subscribe, help the channel grow. I will see you in the next video.